starting.
Our project is called Fashion in Motion. It is created and presented by me, Hillevi.
Shaghayegh.
And Sahara.
Our motivations was that we were inspired by games like The Sims and childhood dress-up games. We wanted to explore spatio-temporal modeling of moving and transforming objects and combine animation, interactivity, and data analysis in a single system. For the educational value, there's a link between constraints, motions, and SQL queries. And our goals, we wanted to model an avatar and interactive clothes using MLPQ constraints. And we wanted to animate movement, color changes, and dance sequences over time. So for our data transformations, the dataset was created in two methods, using manual calculation and through the MATLAB script I2V2C. Due to the restrictions of the MATLAB version, creating moving objects was difficult, so we focused on the first method for majority of our work.
And this is our entity relationship diagram. So in our system, we have a white background with a closet that has doors that open and a dress that moves from the closet to the avatar, and the avatar that has body parts that dance once the dress is on the avatar. So in our diagram, we have 12 entities. We have our background that has a one-to-one relationship with the closet, and both of these are stationary. And the closet has a one-to-many relationship with the doors, including the left and the right door. And this is a one-to-many relationship. And we have the doors that have a many-to-many relationship with the knobs. And these are both our moving objects. And then we have our avatar, which has the body. This has a one-to-one relationship with the head, and the head has a one-to-one relationship with the hair, one-to-many relationship with the eyes, and one-to-one relationship with the mouth. And within this, the head and the hair, and the eyes and the mouth are all moving objects. And the body also has a one-to-one relationship with the dress, a one-to-one relationship right now since we don't have other outfits implemented yet, but could also be a one-to-many relationship in a bigger system. And then it has a one-to-many relationship with the arms, and the arms have a many-to-many relationship with the arm dance. And we have these two as different entities because we have some stationary arms within the arm entity and the moving objects within the arm dance entity. And all of these entities have their attributes of the X and Y coordinates that we calculated for them, and the time constraints, and their respective IDs. And this is kind of the format that we created for our constraint database that we put into MLPQ. It includes all of our entities and our primary keys, which are the background ID, closet ID, door ID, body ID, eye ID, and arm ID.
For our project, we have different ways of using SQL queries. One of them is for finding the constraint for a specific polygon in a specific time. For example, here we are using a basic query to find the head polygon between time of 0 and 10. And during that time, the head is not moving. Here we are trying to find the shape of the dress during the time 5 to 15. And during that time, our dress is moving. Here we have a set query, and here we're trying to find the position of left arm and right arm during the dance interval between times of 16 to 18. And here are the constraints. Here is the demo of our work. As we can see, we have several moving objects, including the closet, doors, doorknob, the avatar itself, the dress, and the dress is also changing color as it moves.
Yeah, so in conclusion, we effectively modeled, animated, and analyzed spatial temporal interactions of objects, which were the closet, the outfit, and the avatar. And we constructed a database schema, an ERD, and MLPQ constraint datasets to represent the objects and their motions. And we presented a visual and analytical framework to show how databases support interactive and time-based simulations, where we implemented the closet opening in a certain amount of time and the dress moving after it has opened and the avatar dancing once the dress has reached the avatar. And for future work, we would probably implement more complex animations, such as more movements of a more detailed avatar, maybe multiple avatars, and like I said earlier, maybe different designs of clothing where we would make a clothes entity and use style and color and clothing ID for its attributes. And overall, this was just a fun way to implement our CSCE 413 project of moving objects using MLPQ.